In the prior video, we presented a simple method to estimate yearly expenses and project their adjustments with inflation over time. We also calculated the required funds for retirement, whether stored as savings or invested with an annual interest rate. In this video, we will explore saving strategies, digging into annual contributions and the advantages of investing with compound growth. Let's move now to our next purple table. Here we're going to calculate the retirement savings. The goal is to save enough money to have the equal or higher amount that would be required to retire. For example, if we can save $1.5 million by the age of 32, we could then retire with our strategy. In the US, we have limits by the IRS on how much money we can contribute to our 401k and other retirement plans. Ideally, the more you contribute each year, the better. You should figure out how much money you currently could afford to contribute in the first year. Suppose you can contribute $10,000 annually. Similar to our expenses, we'll presume that every year we can contribute this amount plus inflation. In the initial year, we'll utilize the $10,000. For the subsequent years, we'll use the previous amount multiplied by 1 plus inflation as an absolute reference. Alternatively, we can employ the FV or future value function mentioned earlier. Let's replicate this equation down to the bottom. In the adjustment column, we have the flexibility to incorporate any additional savings we may choose to add. This could involve modeling scenarios where we receive an inheritance, a bonus, or any extra funds that can contribute to our retirement savings. For instance, we might simulate receiving an additional $50,000 at the age of 30 and incorporating that amount into our retirement savings. The total yearly contributions can be determined by summing up the values from the previous two columns. For now, I will leave the adjustment column empty and hide the corresponding columns. If we've already saved $1,000 for our retirement, we can incorporate this value. On the first row of the retirement savings, we can include this initial amount to account for the existing savings. Each year, we will increase the savings from the preceding year by multiplying it with the interest rate using an absolute reference and adding the contribution for that year. This iterative process ensures the growth of our retirement savings over time. Let's replicate this process throughout the spreadsheet. In the graph, you'll observe a purple line representing our investment in retirement savings, which grows exponentially. Eventually, this purple line, denoting our savings, will surpass the blue line representing the amount needed for retirement. The point of intersection marks the age at which we can comfortably retire. In summary, this video has presented a straightforward approach to illustrate how yearly contributions and compound interest can contribute to the growth of our retirement savings. Once our savings surpass the required amount for retirement, we can use this information to establish the minimum age at which we can retire. In our next video, we will explore the process of determining retirement age, along with insights on modifying the spreadsheet and experimenting with various assumptions to comprehend their impact on our retirement age. If you find this information valuable, consider subscribing to the channel for more insightful content.